Good day, I'm Dr. T and welcome to my office. So today I'd like to talk a little bit about electrical safety. And to be clear, this is an overview, an introduction, not an ending to your exploration of handling electricity in a safe manner. So don't let this be the last word. Keep looking. I'm not covering everything by a lot. Okay, so when we're dealing with electricity, obviously we have energy, and with electricity we can think of a couple of different dangers or scenarios where this can create problems. For starters, whenever you have electricity, obviously we're talking voltage and current, and most of the problems are going to be with current. Voltage is, of course, intimately linked. Remember, voltage equals current times resistance, or how much the thing doesn't want the electricity to flow through. So current and voltage are definitely linked. With high amounts of current, you get high heat. So if you have a wire and it's conducting a lot of current through it, it will warm up. And as it warms up, problems can occur, such as it could ignite things around it and or melt itself. This is why within all reasonably decent electrical settings, there is some form of device to safely stop the flow of current if that current gets too much. This would be your circuit breaker or a fuse. This is also why you don't plug a whole bunch of stuff into one outlet. So, first thing we got to worry about is heat generation. Now, if the current is flowing through you, which of course you don't want it to do, it's going to create heat in the process and it can literally cook you, which of course is bad. Now, a couple other issues we have. Your muscles run on an electrochemical system. If you have an electric current running through you, that's going to interfere with your muscles' ability to do what they're trying to do. Depending on the voltage and the current running through you, you may find it that you can no longer control your muscles, and therefore they will either spontaneously react and twitch, or they will grab hold and won't let you let go. The latter is more of a concern for DC, the former is a little bit more of an AC thing. Of course, you all have one rather important muscle kind of in the middle of you, and that is your heart. And if it doesn't work, you're dead. So electrocution, where you have issues with your heart not working right, can be a very severe problem, and thus you wish to take precautions to avoid this. The other thing you want to worry about a little bit with electricity is the case of arcing. So you have conductors. They conduct electricity. You have insulators. Insulators don't conduct electricity as well. They can still conduct electricity if the voltage is high enough. So if you get two conductors that have a fairly good voltage across them, and they get close enough, then the electricity will just travel through the air. And that you get an arc. Of course, this is very, very high temperature. You get very high current because once you connect two conductors together and there's no device in there to slow the electricity down, no load on it, nothing's going to use up that power, what we call a resistor, then the current just flows freely. You got V equals IR. If R is next to 0, then the current is going to be through the roof and it's going to get very, very hot. Not to mention, if you're arcing through the air, you're turning that into plasma. That's making it very, very hot. That has a great chance of causing burns, starting fire, and to make life even more fun, it will react with the carbon dioxide in the air, converting it into carbon, which is a conductor, and can make the arcing worse by adding a conductive coating to it, and thus bridging the gap. Higher voltage, that's more of a problem. So if you are working with, say, electrical outlets in your house, the 120s, you have to get real close to arc. That is, by the way, why your light switches go and you can't put them in the middle, or at least they really try not to let you, is in the middle, there's potential of arcing. Now, once you're at 220 volts, which is what your stoves may very well be running at, or higher, because there are systems where it's 440 or even higher voltages, arcing becomes a much more serious problem, where you don't have to touch the conductors to get electrocuted. They'll come out and touch you. They'll arc, which of course is not what you want. Okay, so let's talk about a couple of different scenarios where we have some issues. Of course, the classic one is you got the wiring in your house. In the US, we run at 120 volts, which is kind of this balance point between having a high enough voltage that's an efficient conductor. The higher the voltage, the more efficiently you conduct power, but the more damage it can do if it shorts or if it zaps someone. as well as the better it can arc. So lower voltages are generally speaking safer, and thus 120 is what we have decided in the US is adequate. In Europe, they usually have a little bit more advanced plug designs that add some safety there because they're running at 220. And that, of course, more efficient, but a zap on 220, you're going to be a lot worse off. Now, you will notice you've got your plugs. I'm not for sure how well this is going to show up on the camera. This is one to swap out someplace in my house. Anyways, so you got the smiley face on these plugs. Let's talk about the 3 pins real quick. One of these guys is going to be coming from the power plant and is going to have kind of the major oomph behind it. This is going to be your live wire. When you screw it in, it's going to be black. The other one is going to be your neutral, and this is basically allowing the return trip for your electricity. Now, this is AC, so it's back, forth. But typically speaking, the white wire is not the one you have to worry about. It's the black wire. At least not as much. The third one, the one on the bottom, is the grounding pin, and this literally just ties in via some copper wiring to a pole in the ground. The goal here is that this shouldn't be used. The 2 longer slots, which by the way, you'll notice they're different sizes, that some things for safety reasons will make sure that the black is separated from the white and you don't switch them. Although for most electrical applications, it doesn't matter which one goes where. But the grounding pin is so that if something shorts out, something goes wrong, the electricity has a path to follow to get away from the system and not try and follow through you. You will, however, notice in older times they were screwed in like this. Now more modernly, they tend to be screwed in like this with the grounding plug up. Aesthetically, I don't like it, but I totally understand why. And that is, imagine you have something plugged in. So this is a tester, so it sees if I have power, but I don't have it plugged in all the way. Now, if something drops on top of it, if it was in the old configuration, now that can bridge my 2 leads and that can short them. And I've seen this happen. It is not fun. Whereas this way, hopefully it catches on the grounding pin and doesn't cause a short. That said, don't do this. Plug it in. If you're going to plug it in, plug it in. If you're not, don't. Okay, so we've got ourselves some electrical outlets. Whenever you're working on these guys, cut off the power. Make sure you go to your circuit breaker and turn off the power and then test it either with a plug tester or a good old-fashioned voltmeter. Good old nice multimeter. Everyone should own one of these. Before you start messing around with them. Typically speaking, in industrial settings, there's this philosophy of lockout tagout, where if you're going to be working with anything that could have some danger, if some idiot turns it on, you literally put a padlock over the switch. And industrial settings will have holes in the switches such that you can lock them in the off position. And there are specialized padlocks that, hey, this is my padlock, I'm the one running on it. And then everyone who's working on it has their padlock on it. That way, no one can turn it on until they take their padlock off. Now, am I saying to do that in a home setting? At least put a piece of tape over that and tell everyone don't move the tape. So make sure you turn off the power to whatever you're working with, and then, don't let anyone turn it back on while you're working until you're all done. Now, that's a brief discussion of AC. Let's talk DC. DC is in some respects safer and in some respects more dangerous, depending on what's going on. So DC quite often we see in the terms of batteries. So our good old AA cell, which is technically not a battery, or our coin batteries. By the way, these have an interesting threat that most other things don't. Small kids will try and eat these guys. And not only is it electrically shorting in their esophagus bad, the chemical contents are, shall we say, rather nasty if you actually eat them. They're fine as long as they stay well together, but you typically use corrosive compounds in making the innards of these. That's why you don't want to damage the outside coating of your batteries. And eating them damages that, to say the least. Okay, at low voltages, they're not going to arc. They don't have the ability to arc particularly well. And if you get a short, the chemical process is not going to be able to produce enough current in order to get particularly high amounts of current to create problems. So if I was to short the ends of this battery together, which you'll notice is actually intentionally made rather hard to do, that's not going to be a big deal. It's going to drain my battery very quickly. It'll be gone in minutes, if not a couple of hours. But it's not usually going to create any major fire or shock hazards, etc. I can hold it and it's not going to hurt me, even though it's trying to run a current through me right Once I go up to about the 9 volt, that's usually kind of the point where not a big deal. Now, if you have moisture on you, that's going to decrease your resistance. It's easier for the current to flow through you. So don't do this at home. And I don't have my 9 volt here. I wish I had 9 volt. If you, and once again, don't actually do this, but if one were to touch their tongue to the leads of a 9 volt battery, those are the square ones with the two little, the one cup, the one little narrow thing. That doesn't make sense, does it? I'll try and Wikipedia picture over there. Anyways, if you were to touch that with your tongue, you would feel that it's kind of trying to zap you. So, at that point, okay, it's still zapping you. It's still producing enough energy to, kind of maybe do a little bit of arcing, potentially. And so like, okay, safety-wise, this isn't too bad. It's not going to hurt me, but I don't want to be messing with 9 volt batteries. Once they start going up in power, things start to change a little bit. So if I grab a power tool battery, a couple things on this one. One, lithium-ion batteries. If these guys get damaged, the internal chemistry can get a little bit funky, create some hydrogen gas, they swell up, and, well, hydrogen burns really good. So there's a couple of great videos of lithium-ion batteries that have been damaged. Yeah, a huge fireball, which, of course, is not something you want to have anywhere near you. But there's enough voltage in these guys that if I touch the leads, which I'm not going to do, but if I were to touch these two leads together, it could give me a pretty nasty zap. Notice how the leads are kind of recessed. It's really hard. Well, I mean, I could do it. But this would give me a fairly nasty zap, but it's unlikely to. Now, what you'll find is most handheld batteries, or batteries for tools like this, are going to be under about 30 volts. 30 volts is the point where, for DC, somewhere in this 30-ish volt range, is where the current going through your hand is going to be enough that you won't be able to let go. So if I get a nasty zap, that's unpleasant. If I get a nasty zap, but my muscles are contracting so hard that I can't let go, and the current is simply flowing through my hand, cooking my hand until the point where the battery dies, after which my hand is in pretty bad shape, that's bad! So these are usually set a little bit below that point. So this guy's an 18 volt. I usually see them in the 20s. Obviously, you need a bigger battery also. So the more battery you have here, the more it's on your drill. And at a certain point, you don't want to carry that much on your drill. But that does mean that the lawnmower batteries, yes, I use an electric mower. I have asthma. That's why. These guys are 40 to 80 volts. Notice on the back end, don't think you'll be able to see this, but the prongs are much more buried inside of here. You cannot touch these. These are housed well inside the battery. This would be enough to cause some pretty serious issues, not to mention lithium ion. If you mess with lithium ions, once again, you can damage the internal circuitry. They can start arcing, swelling up, and literally exploding. So, moral of that story is, respect your batteries. They've got a lot of energy in them, and, can definitely create problems. One last point on car batteries. From what I've heard from family members with personal experience, getting zapped by 12 volts in the rain kind of scenario, it's very unpleasant. The 12 volt probably won't kill you, but it could definitely hurt you. And there are definitely stories where, people have allowed a car battery to arc to something and it literally welded things together. So you can generate lots of heat in that process. So if it's anything more than a 9 volt battery, respect your batteries and make sure, you don't treat them poorly, and they will provide a wonderful power source for you. But any power source, whether it be a battery, a fuel, big heavy weight suspended, this is a lot of power, or there's a lot of energy here, and energy can, if directed poorly, lead to damage. So anything with lots of energy, you gotta respect no matter what it is. So with that said, I will let you dive deeper into electrical safety for your particular applications. Have a wonderful day and see you in future videos.